Okay, so now for note card 108, we are going to be solving another quadratic linear system by hand using good old noggins and writing down and showing our work. So we have y equals and y equals. If we didn't have y equals, we'd have to get them both set equal to y. And then you can just set them equal. Fancy. Now, when I go to add the 2x here from this side, it's going to be a 4x, so my b term does not go away. All right, so I'm going to need to get it set equal to 0. So I add 2x, I add 2x. I also need to subtract 2. So I get negative x squared plus 4x plus 5 equals 0. Now, I don't want that negative in the front when we're factoring, so let's just go and change the sign of everything. Really, algebraically, you're multiplying both sides by a negative 1. So it'd be x squared minus 4x minus 5 equals 0. And then you factor what times what is negative 5 but adds to give you negative 4. What times what is negative 5 but adds to give you negative 4? That would be negative 5 and 1. And just double check yourself. So x squared plus x minus 5x would give me a minus 4x and then minus 5. Then you do the zero product property, ZPP, where you set each of these equal to 0. And you get x equals 5 and x equals negative 1. That means, guys, we have two intersection points. We have one where the x value is 5, and we have the other where the x value is negative 1. So how do we get the corresponding y values? Well, we go back up here, and you can use either, but I like to use the linear one. I'm going to plug 5 in, get the y value, and plug negative 1 in and get the y value. So y equals negative 2 times 5 plus 2, negative 10 plus 2, y equals negative 8. So our first solution is 5, negative 8. Now I'm going to plug in negative 1. Negative 2, again, I'm plugging in right here. You can plug into either. You get the same y value. So negative 2 times negative 1 plus 2. Y equals 2 plus 2. So y equals 4. So my other solution is negative 1, 4. All right, so I popped in my work right here, and then I wanted you to see Desmos. I typed it into Desmos, and I zoomed out, made it to where I liked it, so I could see the window. Good. And I can see the ordered pairs of intersection are negative 1, 4 and 5, negative 8. So we are good to go. We did it right algebraically. Let's see. We'll put this insert image. Okay, so pause me, finish up note card 108. You guys have done a great job listening to me go through this with a slower internet at my house. But you know what? It all works out. So pause me and finish up this note card. Remy, no.